Digital to analog conversion takes digital data and converts it into an analog signal that we can hear. This digital data can be represented by ones and zeros in a digital file, flashes of light through an optical cable, or a voltage being turned on and off in a conductive wire. Let's look at the difference between a standard chip DAC and a DAC that uses Chord technology. Standard chip DACs are inexpensive. They have predictable, predetermined characteristics, and they're mass-produced. They're in everything that makes a sound, and the same chip could be in an expensive DAC or a simple portable player. Chord, however, takes a very different approach, a much more powerful one. We designed the chip from the ground up with unique coding. With our DAC, we control everything and reproduce the original waveform with astonishing accuracy through the use of Rob Watt's multi-award-winning technologies. Looking at the board itself, you may not initially see a difference. A standard chip DAC uses the standard chip that we talked about earlier. Chord DACs use a very sophisticated, custom-coded, field-programmable gate array, or FPGA. Essentially, this is the powerhouse of the device, where the complex filtering and noise shaping of the digital data takes place. We use FPGAs because they allow us to create a completely custom digital circuit that is several orders of magnitude more complex than a standard chip DAC. The filtered, noise-shaped data from the FPGA is received by the flip-flops, which convert it into an analog signal. Chord uses excellent crystal oscillators. These are the beating heart of the DAC, pulsing a voltage at fixed ultrafine intervals to send data. Jitter sound quality problems are eliminated partly because of the flip-flops having a direct or pure feed from the crystal oscillator. Regular chip DACs typically have an internal feed which succumbs to switching noise running through the silicon of the chip. These regular chip DACs typically operate at a frequency of only 6 MHz, giving poor resolution. Chord oscillators operate around 20 times faster, at a frequency of 104 MHz. We do this in order to faithfully reproduce incredibly small micro details from the original recording. This increased speed also reduces noise, which in turn yields amazing resolving power, so you'll hear things on your recording that you've not experienced before. The WTA interpolation filter is one of the main reasons for acquiring such powerful FPGAs. The WTA filter's primary objective is to reduce the margin of error in terms of timing. This is crucial for reconstructing transients, where these sonic cues are responsible for accuracy, quality and clarity of timbre, articulation, soundstage, pitch and rhythm. This WTA filter has 500 times more processing power than a conventional, industrial or military DAC chip, and is yet another reason to run the crystal oscillator at 104 MHz. The DAC also uses a unique technology, pulse array. Here is an illustrated example of a 10-element pulse array DAC. Many standard DACs use a single element line that switches slowly between states, but this approach has poor resolution. What you can see here is that each individual element has a rising edge of data cancelled by a falling edge. This results in a much higher resolution signal that is immune to jitter. Due to this signal-independent activity, all switching errors are eliminated, which provides benefits when dealing with distortion and noise floor modulation. Noise floor modulation is when the residual noise of a DAC varies with signal. It's very annoying, and regular DACs have very large amounts of it. With Chord DACs, noise floor modulation is not measurable. This gives a very smooth and refined sound quality. Instead of using a semiconductor chip, op-amps or other active electronics, Chord uses a discrete output stage to amplify the converted analog signal directly from the flip-flops. The signal only passes through 5 individual components and helps keep the signal path very simple. Because of this, along with the fact that the volume control is handled digitally inside the FPGA without loss of information, due to Chord's unique oversampling process, there is very low small signal distortion in comparison to using active electronics or signal paths with hundreds of components. Simple, short and tight tolerances of components give us low distortion and noise, A Chord DAC has full control, and it can drive headphones and IEMs down to very high and low impedances. Thus, it perfectly drives all headphones and IEMs. The signal that comes from the DAC itself is unadulterated and completely pure, allowing you to enjoy your music like never before.